Hello, students. Welcome to lesson 10. All right, so you're going to develop a convincing argument establishing that every real number with a repeating decimal is a rational number. This is a long and confusing argument, so if you get lost, don't worry about it. The only thing you need to remember is that repeating decimals are rational numbers because we can make them into fractions, even if you don't remember how. Okay, so let's review fractions and decimals. We know a fraction is a division problem. We know if you divide the numerator by the denominator, you get a decimal. We know the decimal will be either terminating or repeating, and we know irrational numbers cannot be made into a fraction. We know irrational numbers are decimals that go on forever and ever and never repeat. Okay? So to convert a fraction to a decimal, we just divide. 4 divided by 5 gives me 0.8. 15 divided by 6 gives me 2.5. 5 divided by 6 gives me 0.8333 repeating. Okay, pretty easy. To convert a terminating decimal to a fraction is also relatively easy. Technically, what you do is you take the decimal and you put it over 1 because any number over 1 is a fraction and it's the same number. But to get rid of this decimal, you multiply by 10 over 10, right? So 10 times 12.5 will be 1.25, 10. So basically, if you multiply this number by 1,000, you get 125. So if you multiply this number by 1,000, you get 1,000. So 0.125 is 125 over 1,000. And if you read it out loud, it makes sense. This is 125 1,000ths. So it's 125 over 1,000. So basically you say 1, 2, 3 numbers to the right of the decimal place, 1, 2, 3 zeros, put a little 1 there, put the number up here, throw away the decimal place, and I'm all done. Now, repeating decimals are really a lot harder, right? 0.81 repeating, if I put it over 1, that's 0.81 times 100 gives me 81 over 100, but is 81 repeating over 100 the same as 81 over 100? Or in other words, is 81 repeating the same as 0.81? And we know from last lesson, they're not, they're different. So we can't do it the exact same way. So we found a trick. This is where algebra really comes in handy. If we say, hey, let's make this number equal to x, and now I'm going to get rid of this decimal by multiplying by 100, basically. Multiplied by 10, I have 8.181, and then it keeps repeating. Then I multiply by 100, and I get 81.81, and it's still repeating, okay? But we've got the same thing we started with. It just looks different. I know, who cares? So if I subtract x on both sides, they're still equal, right? So 100x minus x is equal to 81.81 repeating minus x. So 100 minus x is 99x's, 81.81 repeating minus x. Well, it doesn't look like I'm doing anything, but remember what x is. So x is 81 repeating. So just look at this right side. So if I have 0.81 repeating minus 0.81 repeating, that cancels out. So this stuff on the right is gone, and I have 99x equals 81. So 99x equals 81 is a pretty simple problem. I divide by 99 on both sides. I have x equals 81 over 99. And it's actually pretty easy. Okay? So when you have repeating decimals and you just start with the repeating decimal, it's really easy. You just count the number of decimal places, and instead of putting zeros, you put nines. So 0.81 repeating is 81 over 99. 0.303 repeating is 303 over 999. That's pretty easy. This is the hard one. So if I have 2.13 and 8 repeating, so if this repeating number is not right next to the decimal point, I get in trouble. Okay, so I can't just say there's 3 decimal places, I'll put 3 nines. Looks like it should work, but it's not. Okay, because if I go through that same process of setting x equal to 2.138 repeating, and I multiply by 100 or 1,000 or whatever, I end up subtracting 2.13 from 0.8. And that's not the same thing. I want to get rid of this repeating number. So think about this for a second. What do you think we have to do differently? Well, I know 0.8 repeating is 8 ninths. So if I can get this 2.13 into 2.13 plus 0.8 repeating, then I can switch the 0.8 with the fraction 8 over 9. So 2.13 sets equal to 100, like I just did. I multiply it by 100, I've got 2.13.8 repeating. And I know, if I went back to my last rule, 0.8 repeating is 8 over 9. So this is actually 213 plus 8 over 9. Okay. Now I can make 213 into a fraction and add it to 8 ninths. So I've got 100x equals 1,925 over 9. 213 times 9 over 9 plus 8 over 9. If you do the math, ends up being 1,925 over 9. So now I've got 100x equals 1,925 over 9. I can divide by 100 on both sides, and it goes 1,925 over 900. Okay? There's no real easy way to get here. You're going to multiply by tens till you get just to your repeating decimal. You're going to make that repeating decimal into a fraction. You're going to add that numbers in front to that fraction. Then you're going to divide by the number of tens you originally multiplied by. And that will give you your fraction. It's a lot of work, but like I said, the only thing you have to remember is every repeating decimal can be made into a fraction. Sometimes it's easy, sometimes it's hard, but if they can be made into a fraction, then they must be rational numbers. And that's the important part, is identifying repeating decimals as rational numbers.